What's up, guys? Let's take a look at another CodeWars exercise. This one's called Sum Strings as Numbers. We get two numbers, we have to add them, but the problem is they're huge, 1,000,000 digits, maybe. And so what you might assume of just converting string to int or int to string is not going to work to do that all at once. Let's try it anyway and see what happens. If we go int x plus int y, and then we stir the whole thing, well, it'll work for the small tests because that is the idea. But when we hit attempt, we have two errors actually. One of them is for the overload with too many digits. Apparently 4,300 is as far as we can go. And then one of them is the opposite. What if we have no digits at all and they don't know how to handle that? So we might have to treat that separately, or it might just naturally happen along the way. Let's forget about that one for now. Let's say, okay, I need to do what I did in second grade. You line up the columns and then you add the ones, add the tens, add the hundreds, each time maybe carrying over a little extra. So if I do like 5 plus 4 and I get a 9, that's fine. But if I do 5 plus 8 and I get a 13, well then I have the 3 here and the 1 carries over to the next biggest digit, regardless of what that is, right? Like maybe I'm going from 1s to 10s, or maybe I'm going from 10 million to the next. It's still the same idea. So I think for this, I'm going to use my lovely favorite zip. We're going to zip these two and go one at a time. X and Y, and let's print digit and other, and we might see what goes wrong at the very beginning, which is that they give us a test of like 123 plus 456, and I don't want to add the 1 and 4. I have to save that for last because they might have some overflow from the previous, so I have to add the ones on the right. And what I'd want to do is like reversed zip, but they don't let you do that. So I have to reverse the individual ones. And then you might think, oh, well, we'll just do like the negative slice to go backwards. And that does work, but if they're really giving us 1,000,000 digits, I don't want to make a copy of 1,000,000 digits. That seems wasteful. Instead, the reversed function will iterate one at a time and not take up all the memory at once. Seems nice. And then let's run that again to see if it prints it quote unquote backwards, right? The 3 and the 6 are the rightmost column if we had lined them up like you do in elementary, you know? So now we've got our stuff and we need to figure out, okay, I'm going to add them, which I can't because they're still strings. And then I want to see if there's enough for this slot or maybe some carryover to the next. Okay, so I'm going to say int digit plus int other. And remember, this is just one at a time, so we're not worried about the speed. If I have to int a 7, that's fine. If I had to int, you know, a zillion digits, that's the problem. Plus the carry, right? We're not going to have a carry on the first one, but on all the other ones we might. So we have to add that and that and that. And then we have to separate it again, because what if I have like a 9 and a 9 and I get an 18? Well, then I have to put the 8 down here and then the 1 on the next guy. So I could convert it to a string and take the digits of the string, but that seems annoying. I'd rather use another function. Here's why I thought of this other function. This reminds me a lot of the making change problem. If you have coins and you need to pull out quarters and then dimes and then nickels. This reminds me a lot of the Roman numeral problem. If you have a quantity and you need to take out, you know, L's and X's and V's. They are taking a chunk and then seeing what's left. And for that, you use a function called divmod. And we can do the same thing here. So I'm going to go carry, and then we need a name for this place or this column. I think I'm going to call it column equals div mod of that stuff. And what are we dividing by? 10. Okay, so the lowest number you could possibly have is 0. And the highest you can have in this case is 18 maybe, or 19 if we have 2 9s and a carry. But we don't have to worry about more than that. We're not going to have like 20 something. Although, you never know, right? It could surprise us. So, we're going to try that. And then let's print those things to see if we're doing it. Oh my gosh. We got to start. Initialize. Okay. So now we've got like, okay, on this one, when we add 1, 2, 3, and 4, 5, 6, we get never enough to carry over. So let's hit attempt and get some of this on the big ones, even though none of them are going to pass, right? So we got like, okay. So on this one, we had 2 things that add up to 10. Maybe it was 7 and 3 or 5 and 5, and then we have a 1 overflow to the next, which is great. And I just wanted to see a long one so we can see that it's never more than 1. It's like it's either 0 or 1. It's really a Boolean for that carry. Do I carry, yes or no? Which is the same as what it would be in binary or whatever, right? So that's great. Let's see if we can use it for something. Well, we're going to put it in a list. Let's say results, and then we'll go result.append column, and then at the end we'll put that back into a string, right? Or not print, we'll return, because we're not ready yet really to pass some tests, but I think we're ready to pass one test. Let's say results, except they have to be strings again because they're ints. So I'm going to go map stir result, and then we have to join them up again. So we're going to go join, and let's see if that's enough to just barely get something going. Hey, look at that. We passed one test. And if I hit attempt, we might get slightly more than 1. Oh my gosh, 4. We're geniuses. And that's really good because when you go from 0 to something, that's a big jump, right? Maybe later we'll go from like 25 to 26, who cares? But that initial thing where at least now we know we're doing something, we're given the right kind of output, that's pretty good. So what are we missing? What's wrong? Well, mostly it's backwards, right? We reversed them on the way in, but we didn't reverse them back on the way out. So I can put a reverse in there, and that should help a little bit. Okay, I passed the 2 initial ones. How about the attempt? 7. Okay, well, that's something. What else do we have? Well, we have this issue of, well, you know what? Let's look at the results and see if we notice anything. We have some blanks. That's easy to handle. We can say if this was nothing, we can go or 0. Okay. So like if they give us a blank for one of these, we just say or 0, and hey, now it's moving up. It went from 4 to 7 to 9. Okay. Now what about these? I don't know if you noticed, but they're all fine while being too short, right? Like 0, there is a 0. 11, there is an 11. 301, there is a 301. But they're missing something. So if you notice, we have this issue of if I've got, 20 plus 10, well, that's 30. But if I have 20 plus 80, well, my answer is going to be too big. My answer is going to be more columns than were in the initial. Are they called add-ins, the things that you're adding? Yeah, add-ins are the things that you're adding. So I might have an extra on the end. So I have to say, like, what if there was one left over? We should have more than 9. Oops. What went wrong? Let's see. I think one of these passed that didn't before, but we lost some that did. Okay. So here's an issue. A lot of them got a 0. So this isn't really wrong, because like 02 is really the same as 2, but unless we convert it to an int, that's not going to fall off naturally. So let's say dot strip, no, L strip, because we only want to take a 0 off the left. If we took a 0 off the right, it would actually change the number. It would change like 40 to 4, right? But 040 turning to 40s is good, right? So that's one little bit we can fix. But there's obviously one big thing we haven't fixed, which is, hey, I'm not actually adding all the numbers, because everything we've done so far is assuming that they're the same digits, like 123 plus 456. Okay, what if it was 123 plus 56? And like they don't line up. One of them's 3 long and one of them's only 2, so we can't just magically know what to do with the zip. Zip goes as far as it can with every slot. So if we're zipping 2 things, it needs 2 things. And when one of them runs out, the whole thing runs out. So this is a classic thing. It very often happens that you want to zip and then keep going when one of them runs out. So there's a sister function called zip longest, but you have to import it. Okay, from itertools import zip longest, and it does exactly the same thing. It takes 2 iterables and lines them up, except it has a default that you can fill in. Like if one of them runs out, you can say, oh yeah, just put a 0 in there, which is what we want, right? Because if it's like 123 plus 56, we want a 0 in that left. It's like 056, right? So they have a thing. I think it's called fill value. Let's give that a try. It didn't ruin the baby ones. And it is a little slow. Okay, it did work for all the big ones. That's great. Now I might look at this and figure out some slight changes, or maybe I don't like the names anymore. But this is basically it. We have a very similar pattern to the making change problem or the Roman numeral problem. Let's take a glance at the problem or the solutions from others and see how they did it. Here's one that is exactly the same as mine with different names, right? Like we have the carry, we have the result, we go through, we're going backwards, we div mod, same thing, beautiful. They even have the or 0 just like we did. They even have the L strip just like we did. So don't get thrown off by the superficial differences of like, oh, they used zfill instead of zip longest. It's doing the same job. Or oh, they used slicing instead of reversed. It's doing the same job. I think mine is slightly nicer to read sometimes. I think maybe mine is slightly more efficient sometimes, but maybe I'm wrong. Who knows? Here's another one. Oops. The magic of Python is that there's always a module to import with a function that does exactly what you want. So that's pretty interesting. We'll have to look into how they do this. Is it just big integers, or do they really treat it as strings and do like a separate thing? I don't know. Here's one where they use decimal, which is a, you know, multi-purpose thing to hold different types of numbers. For example, if you don't want floating point imprecision, you can say, no, this is a decimal. We're actually keeping, for example, when you're handling money, you don't want it to be off by a tiny bit. And apparently there's a way to bump up the maximum, kind of, you know, and then you can int like we tried. Here's one that did, even more like what we did with the zip longest, and then you Yep. They're turning them into ints all along the way when you map, which is the same thing as turning it into ints right here. However, I think it's about the same. Totally fine. They're doing, yep. Now they don't have to worry about the or 0 thing. I wonder where that comes in. Oh, they did it at the beginning and they caught it even before entering the loop. That's nice. So if you look at these, they're pretty darn similar, even though they might use different ideas. And this was a great problem. Even though it's like a 4, it's a 4 queue, it's doing simple stuff, and it's about avoiding the tricks instead of diving into the tricks, unless you're one of those people who imported whatever. What is this? Okay, so it's just actually doing it, just really fast and optimized. That's cool. I'll read about this later. Thanks.